and everything, what do you think you're going to find?
Okay, in this video, we're going to pick up on that same function notation. We're actually on this ultimately leading up to having the skill to evaluate this expression here at the end, okay? And this expression here at the end that we're building up towards being able to do is not just a random thing I'm doing to torture you. It's a really important expression that's called the difference quotient. And it forms the basis for the definition of the derivative in calculus. And so we're working on the algebra that's going to enable us to be able to do derivatives later in calculus. Okay. So last video we looked at a linear example. We looked at a quadratic example. And so now I wanted to look at a rational example. Okay. So the algebra gets a little more tedious on this. You can handle it. You had to deal with them in Math 100 and you did just fine, a lot of you. So, but it is a little more tedious than what you were doing. Okay. So for instance, watch this. If I try to do f of 3, I'm going to get 1 over 3 minus 3. Well, that's a problem because I get a 0 in the denominator. So f of 3 is actually undefined. You can't divide by 0. See that? Get rid of that stray mark over there. All right, let's try f of negative 2. So if I'm dealing with this rule, I'm going to plug in the negative 2 where the x is and just simplify, and I get 1 over negative 5, which, by the way, is negative 1/5, either out in front or on top. Move that over a little bit. So usually you write it either on top or out in front of the whole fraction. Because of the way we say it, we say negative 1/5. All right, now f of a, like on the others, can just feel like a trick question because you're not doing any work. There's no simplifying. You're just replacing x with a. So that's all there is to that one. All right, now we're getting into the important things. All right, f of x plus 1 versus f of x, close the parenthesis, plus 2. Let's look at f of x plus 1. We need to do 1 over our input, take away 3. All right, that was the rule. Take your 1 over your input, take away 3. So there's just a little bit of simplifying we can do because below the 1, we actually have x minus 2 now. So we just created a new rule. Okay. All right, now this next one, f of x, close the parenthesis, plus 2. That's like an expression we're going to simplify. And because we're dealing with a rational expression, there's going to be a little more algebra on this. So f of x was 1 over x minus 3, and now we're adding 2 to that. So these are two terms. And I'm dealing with fractions. So if I want to get this combined into 1, I need to change the denominator, which is understood to be a 1. I need to make it an x minus 3 so I can combine those. Okay, so I'm trying to get a common denominator. So I have to rewrite the 2 by multiplying the top and the bottom by x minus 3. All right, we're almost there now. That's just some of the stuff that has to happen on this. Okay, so now I've got my denominator to be x minus 3. You see it? And so what I have is the 1 from here plus 2 times x minus 3. And if you don't mind, let's go ahead and distribute that. So 1 plus 2x minus 6. All of that over x minus 3. Okay. And then let's simplify the numerator. It becomes 2x minus 5 over x minus 3. And don't try to go further than you can mathematically. The x on top is not a factor, neither is the x on the bottom. So you can't cancel those x's. This would be your final answer. Okay. All right, now when we do f of x plus h, it's going to be a lot like the f of x plus 1. It's almost the same. We're going to do 1 over the x plus h minus the 3. So that's 1 over x plus h minus 3, and that's all I can do on that one. Okay. All right, so really this worksheet was trying to build up to you being able to find the difference quotient. That's the expression over here on the left. So that's what we were really trying to get ready to do. So let's go ahead and plug in this box, but then we'll have to go to a new sheet to actually simplify. So remember how that expression is really a formula? So in place of f of x plus h, I'm going to put 1 over x plus h minus 3. There you have it. In place of f of x, I'm going to put 1 over x minus 3 because that's what f of x was defined to be. The formula has the minus divided by the h. Okay, so that's basically what you have, but all you got to do from here to the end is get that expression simplified. Okay? All right, so I'm going to move down on here to the next sheet, find an open spot, finish that up. Okay, you ready? All right, so that was the linear one, that was the quadratic one. So let's go right here. So we have 1 over x plus h minus 3 minus 1 over x minus 3, all of that divided by h. So that's what I got to simplify. Okay. So that means over here, okay, that means what I got to do is get a common denominator between these two things. All right. So it's kind of like if you were doing, let me write it up here, if you're doing 1/2 minus 1/5, you'd have to get a common denominator of 10. And to do that, you'd have to multiply over here by 5 on the top and bottom and over here by 2. Okay, that's the kind of thing I got to do. So over here, I have to multiply the top and bottom by x plus h minus 3. Over here, I have to multiply the top and bottom by x minus 3 to get that common denominator. Okay. All right, so this is x minus 3. Okay. And then minus x plus h minus 3 all over the denominator we created. But don't forget all of that is divided by h. Okay. All right, so that's x minus 3 minus x minus h plus 3, because remember that -1 gets distributed, divided by this denominator we created. And then all of that, when we're done, gets divided by h. Okay, I'm going to go over here. All right, I hope you're following along okay. We're just working on simplifying. And so here now we have the x's are canceling, the -3 and the +3 are canceling. So now we have a negative h on top divided by this denominator we created still that we don't need to multiply out. And then I want you to think about this. See this fraction bar right here? Okay, that's the same as division. When you have that h down there, it's like you now have to divide by h. So I'm going to change it to divide by h. That's what that means. Okay. And so remember how when you're dividing fractions, you keep. Change to multiplication and then flip. So that becomes -h. See, this is like just one, we might be able to just think of it this way. That's just multiplication is just multiplying straight across. So that negative h on top and that h on the bottom, you can cancel that out. H would go here, give you just that, just a 1. Let me do it in blue. So when you cancel this out, you just have a negative 1 times 1. That's negative 1 on top, and then x minus 3 times x plus h minus 3 on the bottom, right? And that's as simple as that gets. All right, so that particular one had a lot of tedious algebra, and that's like our job in pre-calculus, is to be comfortable with doing that. Okay, so that expression right there at the end became negative 1 over x minus 3 times x plus h minus 3. That was the final version right there. And that algebra that it took to go from here to here, that's what we do in a pre-calculus class. Okay. Now I want to tell you just a little bit more about what the difference quotient really is. Okay. This expression that we've been working with, let me see if I can get to a new page. It'll let me. Okay. All right, so when we did this expression, f of x plus h minus f of x all over h, and we were working that out, that's called the difference quotient. Okay. It's really just slope. Okay. And then it's used to find the derivative of a function when you're in calculus. So basically, derivative, slope, difference quotient, it's all the same thing. Okay? All right, so I want to show you, just give you a glimpse of what you do in calculus with what you find in your algebra. So you know how when we did the difference quotient for the function f of x equals 1 over x minus 3, okay, we wound up with negative 1 over x minus 3 times x, what was it, x plus h, yeah. X plus h minus 3. That's what we wound up with when we did the difference quotient. That's what it was. Okay, and all that's our job. That's what I need to teach you how to do. All right, what happens in calculus? In calculus, we add this notation out in front of that. We find the limit as h approaches 0 of this expression you just did. Okay. And if we look at the limit of that as h approaches 0, as this goes to 0, the h goes to 0, then that would turn into the limit of the expression as h goes to 0 would turn out to be negative 1 over x minus 3 times x minus 3. Be negative 1 over the x minus 3 squared. And that right there is the derivative of f of x equals 1 over x minus 3. So see, the calculus folks, they just get to add that to it, okay, to your difference quotient. Okay, so this is the difference quotient. When you throw the limit as h approaches 0 of that, okay, that right there is the derivative. Okay. And for this particular function, we wound up simplifying it to be negative 1 over x minus 3 squared. Okay, so I just wanted to give you a sense of that. All right, I think I'll also, no, I won't. All right, so that's it for this video.